Welcome to yet another edition of Brain Maths. On today's edition, we will be looking at laws of logarithm. Before I proceed, if you are just joining us on this program, don't forget to subscribe to this channel and to also turn on the notification so that you will be among the first to be notified when a new video is released. Coming back to laws of logarithm, we have many rules under logarithm, but the first one says logarithm to base a of m multiplied by n. The m may be anything, it could be another variable, but in this case we have m and n. So this will give us the expansion logarithm in base a of m plus logarithm in base a of n. Don't forget that if you are expanding indices, that is having multiplication, you also add the powers together. So the same thing is applicable here. For example, if you are given logarithm in base 2 of 8 times 16, this can be expanded to logarithm in base 2 of 8 plus logarithm in base 2 of 16. Also, if you have logarithm in base 3 of 9 times 3, expanding this will lead us to logarithm in base 3 of 9 plus logarithm in base 3 of 3. The second law says logarithm in base a of m over n is expanded as logarithm in base a of m minus, the minus is coming from the division, logarithm in base a of n. For example, if you have logarithm in base a, in base 3 of 27 over 81, this is expanded as logarithm in base 3 of 27 minus logarithm in base 3 of 81. Also, if you have logarithm in base 4 of 64 over 32, this can be expanded as logarithm in base 4 of 64 minus logarithm in base 4 of 32. And the third law states logarithm in base a of m, that is having a power of n. Maybe after you have expanded and you have gotten the indices of your logarithm number, what this is saying is that whatever power you have here, you can bring it to the front of the logarithm. So this will lead us to n, which is the power for logarithm in base a of n. The example for this may be logarithm in base 2 of 8 raised to power 2. So all we need to do here is just to bring down this power, which is 2. What do we have left? We have logarithm in base 2 of 8. So these are the three major rules of logarithm. But we have some special rules and special cases, and that is what we'll be taking next. Don't forget from our previous lessons that we said whenever we have a whole number that is equal to another number having a power of 1. The logarithm of this will be the logarithm to the base of the answer given to us of a, which is the whole number, equals to 1. So the first special logarithm says logarithm to base a of a equals to 1. What this implies is that if you have any logarithm having the same base and the same number, it will always give you 1. Similarly, if you have logarithm in base 3 of 3, this will also give us 1. For every number, this is true. The second special logarithm, don't forget as well that said whenever you're given a number, look at this, a raised to power 0 equals to what? 1. Any number in the world that is raising to the power of 0 will always give us what? 1. So for this, if you want to write the logarithm for this number, it is going to be logarithm to the base a of 1 equals to 0. So this is another special logarithm. For example, if you have logarithm to base 2 of 1, the answer will give us 0. The third special logarithm says logarithm to base a of 1 over a equals minus 1. Where have we derived this? If you don't forget as well from our previous lessons, we said whenever we have a raised to power minus 1, a raised to power minus 1 can be rewritten as 1 over a. So if this is given to us as an index, we can rewrite it in logarithm, taking logarithm to the base a of the number given to us, which is 1 over a, and this one will come back to its power side. So for every logarithm in this format, take an example of logarithm in base 2 of 1 over 2. Logarithm in base 2 of 1 over 2. If we expand this, will give us minus 1. Because we can rewrite this as 2 raised to power minus 1. So let me break this down quickly. If you take this as an account, we have logarithm in base 2 of 1 over 2. If we break this down, we can rewrite it as logarithm in base 2. 1 over 2 is written as 2 raised to power minus 1. And if this 2 raised to power minus 1 is taken into account as well, we can bring down the minus 1 from what we have done here, that whenever you have a power, you can bring down the power. So if this power comes down, we have minus 1 multiplied by logarithm in base 2 of 2. And if you still come back to what we have done here, we say whenever a logarithm is having the same base and the same power, it is equal to 1. So if this is equal to 1, then our answer will be what? Minus 1. And the last one, which is going to be the fourth rule, says logarithm in base a of 1 over x. Now, let's look at this together. If we break this down from what we have been doing in the past, we say logarithm in base a, this can be written as x raised to power minus 1. And if that is broken down, we have logarithm in base a of 1 minus logarithm in base a of x. So we have logarithm in base a of 1. We have done that here. Logarithm in base a of 1 will give us 0 minus logarithm in base a of x. So our answer for this will be minus logarithm in base a of x. On this note, we have come to the end of the laws of logarithm. In our next class, we'll try as much as possible to solve as many problems as possible on the laws of logarithm. Don't forget to subscribe to this channel and also try as much as possible to turn on the notification so that you'll be among the first to be notified when a new video is released. Until I come your way next time, do have a wonderful day.